All right, guys, we will begin our bearings and navigation section with a definition of what a bearing is. A bearing is a direction, path, to or from another physical point space. When we're going at a certain or coming from a bearing, that's just a direction. Now we have two different types of terminology, two different types of notations for bearings. We have bearing of. And this bearing of terminology, okay, to figure out the direction, this is going to be a bearing of. This is bearing from true north, where north equals 0 degrees, we go clockwise. Okay? So as you can see in this first example, a bearing of 159 degrees, a bearing of 4 degrees. Okay? When you see those words bearing of, north, that 0 degree line, we are going to be opening up clockwise. Okay, so if you want to figure out the direction of the bearing, okay, we got to start with that north line, and we'll open up 159 degrees, or we're going to open up 4 degrees. And now we have our kind of double direction, okay, where we have two directions, okay. Depending on what direction it is, you'll see down here we have a north and an east, we have a south and a west. Really, we read this almost backwards. It's B degrees, really degrees B of A. So if we look down here, this terminology means 53 degrees east of north. This terminology means 23 degrees west of south. Words need to mean something to us. Okay? So we have those two different notations for bearings, and we're going to draw these out here. Okay? We always need a starting spot, okay? A beginning position. Okay? All right. So 53 degrees east of north. Anytime we're using this, okay, we're going to use here we are. Okay, this is going to be our starting position. Okay? We're always going to draw a north-south, what we call a line orientation. This is going to give us our north and our south. What we want to do is we want to open up 53 degrees east of north. Right? Here's north, here's south. Here's east, here's west. Right? East of north. So we're on the north line, and now you guys are just going to be estimating where 53 degrees is. Here's 45 in my opinion, so we'll just go, we're going to open up just past 45 in my estimation, 53 degrees. We're going to draw an arrow. That is our direction. This direction is 53 degrees east of north. How long should we be drawing this line? We're not at that part of these problems yet. Once we get into word problems, this path, we might have a length to that path. Like we traveled on this, at this bearing, on this path for 700 feet, let's say. Okay? But here we're just practicing understanding the directions. All right, part B, a bearing of 159 degrees. So here's our starting point. Our starting point. We always start from north with the bearing of terminology, and we always open up clockwise. 159 degrees is going to be past 90, right, and almost all the way to 200 or to 180. Open up all the way past 90, pretty close to 180. We'll call that a 159 degree. That means from our starting point, that would be the direction of that bearing. That would be the direction we're traveling. So this, although it becomes important, all right, depending on what you're looking for in a problem, this tells you this path. All right, let's do the next one. 23 degrees west of south. Start here. West of south. I'm just going to draw my south line. We know west would be to the left. I'm opening up kind of a small amount of degrees, only 23 degrees. So I'm going to call this my 23 degrees. This is west of south, which means that would be the direction that I'm traveling on. Last but not least, a bearing of 324 degrees. Starting point, we have the bearing of terminology. We always start north with our 0 degree line. We're going to go clockwise because that's what that bearing of means. We're going 324 degrees all the way past 90, all the way past 180, all the way past 270, and an extra 54 degrees here. Estimating it to be approximately on that. Okay. Now, one more thing I want to talk about to write in our notes prior to getting into these word problems is a reminder of alternate interior angles in geometry. Many times in these word problems, you might see two vertical lines of orientation and maybe some sort of bearing has taken us in that direction. Remember that since these are both vertical, these lines are parallel, that would make these alternate interior angles. That would make those congruent. Just a reminder that these two angles here would add up to 180 degrees because it's a linear pair. We call those supplementary. A reminder of that. A reminder if we have a vertical line and a horizontal line, some sort of bearing here, that these two angles would add up to 90. Those complementary angles. So a little recap of geometry. You might see things like this when we get into these word problems. So I flipped to the back of the page in this example, and I took the liberty of drawing a diagram of what's going on here without really labeling anything. Okay? So we read, Mark notices that the bearing of a tree on the opposite bank of a river flowing north, here's the river flowing north, 115.45 degrees. Lisa is on the same bank as Mark, but 428.3 meters away. She notices that the bearing of the tree is 45.47. So, what I did, I understand bearings pretty well, so I knew that Mark would have to be further north than Lisa, just based on the bearing from them to the tree. Like, we always start with north with the bearing of terminology, so I knew Mark would be going past 90 degrees and then in kind of like the southeast direction, while Lisa, starting from the north, was only 45 degrees, so I knew the tree was northeast of her. Okay, that might take a little bit of time for you guys to get a hang of. Let's put these bearings on. So from Mark to the tree, 115.45. Here's north, that's our 0 degree. We open up past 90 and another 25.45 degrees to the tree. This angle would be 115.45 degrees. The bearing. From Lisa, again, here's north. This is our 0 degree line. We're going to open up 45.47 degrees. 45 degrees. Right, so we have all the information that we've been given here. It says the two banks are parallel. What is the distance from Mark to the tree and Lisa to the tree? So let's make that an X and a Y. What is the distance across the river? All right, guys, so here we go. Work on our first bearing problem. Now, this is not a right triangle. It doesn't look like it. We can actually prove that it's not. But the first thing we have to do is understand that we have one side of this triangle, 428.3. We have another angle inside the triangle, but we don't have a third piece of information. As you guys have seen when using law of sines and cosines, we need three pieces of information. Where will that third piece come from? It's going to come from this angle here. On the previous part of the notes, I just talked about supplementary angles. Straight line, linear pair, that makes this angle 64.55 degrees. Right. The next thing I can do here is to find the angle of the tree here. Right? We actually, to be honest, we do need this. We are going to need this. So 180 minus these two, 180 minus 110.02 degrees is 69.8 degrees. And now we're going to use law of sines. We were given an angle, side, angle case. Angle, side, angle. We know that leads to law of sines. Let's set up our proportion. To solve for x, we're going to do sine of 69.98. Sine of an angle over its opposite side, 428.3, equals sine of 45.47 all over x. We cross multiply, we divide. And putting that into the calculator, x equals 324.97. Alright, we would do the same thing to solve for y. Sine of 69.98 over 428.3, sine of an angle over its opposite side equals sine of 64.55 over y. We cross multiply, we divide. And putting that into our would get us 411.61. Okay. All right, let's put this into some good word problem terminology here, because x and y we defined. The questions are the distance from Mark and Lisa. So from Mark, the tree is 324.97 meters away. From Lisa, 411.61 meters away. All right, good. Now that we know that, guys, we actually should be able to find the horizontal distance across the river. I'm not going to do this in too big of a fashion. Maybe we'll just get it set up. So if I want to find the horizontal distance across the river, drawing it at the right point based on our information would be great. So from Mark, I'm going to draw a horizontal line here. Now, since this is horizontal and this is true north, we know that's a right angle. Since this is a right angle, 90 minus 64.55 gives me 25.45 degrees. And we know that x was 324.97 meters. Now we could use SOHCAHTOA. Okay. If we're looking for this length here, we'll call this z. Then cosine of 25.45. Cosine of this angle would be adjacent, which is z, over the hypotenuse of that right triangle, 324.97. Multiply both sides by 324.97 and plug into your calculator, and we would get z equals 293.44 meters. So distance across the river, 293.44 meters. And that's it for example 1.